Hi, my name is Clayton. I'm one of the tutors at the Natural Sciences Tutoring Center here at Scottsdale Community College. This series of videos is designed to just help you better understand stereochemistry. So that would be Chapter 5 of your organic chemistry material if you're using the Wade book with Dr. Mao's class. I don't know how many videos it's going to be, but basically what I'm going to be doing is working through a handful of problems. I'm just going to show you my personal problem-solving strategy. And if it helps you, awesome. If not, either way, you can stop into the tutoring center and get some help on anything that you're having trouble with. All right, so let's jump right into it and get started here. First thing we're going to do is I pulled 5 compounds out, 5 problems that we'll solve here. And we're going to identify chiral carbons, and we will determine the absolute configuration of those carbons, and we will determine if the compound itself is chiral. So let's get started. Okay, for this first one here, this is pretty much your quintessential chiral carbon. You have a lone carbon and it has 4 unique substituents. So we have a hydrogen, we have a methyl group, we have an alcohol group, we have a chlorine. 4 unique substituents on this thing. So we know already that carbon is chiral. By definition, a chiral carbon has 4 unique substituents. You might also hear be called an asymmetric carbon. So the chiral carbon, asymmetric carbon, that's the same thing. So now to determine the absolute configuration, we have to label the priorities of each of our substituents here. So priority is determined by the weight of the atoms attached directly to that carbon. In the event of a tie, then you have to go to the next carbons out or the next atoms out to break the tie. In this case, we won't have to do that. I have a chlorine, I have an oxygen, a carbon, and a hydrogen. So the heaviest is going to be the chlorine, so that's number 1. Then we have the oxygen, then a carbon, then our hydrogen. So we've labeled our priorities properly. Now the next part of assigning our configuration says that we have to put the 4th substituent in the back. So what I'm actually going to do here is redraw this compound such that the hydrogen is in the back, okay? So I'm just going to kind of tilt it up in the way that I'm drawing it here. So give me a second. Okay, so what I have on the screen here, that is exactly equivalent to this. All I did was kind of tilt it, I just tilted it up like that maybe. So the H now is in the back. When you bring that H to the back, it brings our OH group straight up, right? So it's going like this to this. And then the chlorine's on the left, the methyl is on the right. Let's relabel here. I have 1, 2, 3, 4. In this case, our 4 substituent is to the back. So I'm going to circle now from 1 to 2 to 3. In this direction, it's clockwise. Therefore, the absolute configuration is R. Finally, we can determine if this compound is chiral. Easily said, if we only have 1 chiral carbon or 1 chiral center within a compound, then it's chiral. So this only has 1 chiral center. We can move forward. It is a chiral compound. All right, so I'm going to move a little faster through the next ones. I'm not going to re-explain how to get the priorities every single time. I just want to show you and kind of walk through my problem-solving strategy, and then we'll go from there. All right, here we have problem number 2. So first thing we want to do is identify our chiral carbons. I'm going to look at this carbon first. And what I'm going to do is just draw the hydrogen that's not already drawn on there. So if I look at this thing, I have an alcohol, I have an H, I have whatever this whole mess is, and then I have a methyl. So we can see that is 4 unique substituents. So this carbon here is indeed chiral. Let's look at this next one here. I'll use red for this one. And again, I'm going to draw the hydrogen that's not drawn. In this case, we have a chlorine, we have a bromine, we have this whole mess, and then we have a hydrogen. So once again, we have chiral carbon. So we have 2 chiral carbons on this one. I'm going to go with the left one first. And actually what I'm going to do is redraw this, so bear with me here. Okay, so on the left one that I drew down below here, we're going to focus on the labeled carbon there, the orange one. On the right one, we'll focus on the right carbon there, the right chiral carbon. All right, so we can start here. So I know right off the bat, that's going to be my first priority, that's my fourth. Now here, I have a carbon and a carbon. So that's tied. Now I have to move to the next atoms that these carbons are bonded to determine which is more important. So I know that this carbon here has 3 hydrogens bonded to it. The one on the right has a chlorine, a bromine, and hydrogen. So now I'm asking myself, what's more important? 3 hydrogens or a chlorine, bromine, and hydrogen? And of course, we know that the chlorine and bromine are higher priority than the hydrogen. So there's my second, there's my third. In this case, our fourth substituent is already to the back. So when I make my circle, that is counterclockwise, that's going to be S. All right, moving on to the next one here. Now I can see, okay, bromine is heavier than chlorine, so there's 1, 2. Here there's a carbon, which beats out our hydrogen. Once again, our fourth substituent is already to the back. So when I make my circle here, going around like this, that is counterclockwise. Once again, we have S. That solves number 2. Oh yeah, and here we have 2 chiral carbons. So we just got to make sure that there isn't an internal plane of symmetry. In this case, if I go back here and look at this, I have on the right side a chlorine, a bromine, blah, blah, blah. On the left side, I have this oxygen. So we can see there's no internal plane of symmetry within this compound. So it is also chiral. Okay, for our third one here, we have right off the rip 3 chiral carbons. We can see this is a Fischer projection. The last 2 were perspective drawings. And so Fischer projection is real nice because it makes it kind of easy to see things. I actually like Fischer projections a lot. So these 3 chiral carbons, we're going to label these right off the bat. O, that's going to be number 1. Hydrogen is going to be number 4. Here I have a carbon and then another carbon here. So now I need to break a tie. The carbon up here is bonded to 3 hydrogens. This carbon down here is bonded to an O, a C, and an H. So this carbon takes priority. This is going to be number 2. This is going to be number 3. So in this case, we're going around like this. 1, 2, 3, but something we have to keep in mind, this hydrogen is actually coming toward us. So even though this is clockwise, I'm going to have to flip it because I know that I need my fourth substituent to be going to the back. So what looks like R initially, when we look at it from the back side, is actually S. All right, let's move on to the next one here. Erase that real quick. All right, so I'll use orange here. So now once again we have an O and an H. Those are easy. So there's number 1, there's number 4. And again, right here we have our number 4 coming to the front. So we know whatever we get, we're gonna have to flip that. So now, again, I'm gonna look at this carbon versus this carbon. So in this case, this carbon is bonded to an O, an H, and a C. This carbon is also bonded to an O, an H, and a C. So now I have to go one more. Now I'm going to compare this carbon to this carbon because we still have a tie. So now this carbon is bonded to 3 H's. This carbon is bonded to 2 H's and another carbon. Well, that's all we need to know. This side down here is more important than this side. So there's our number 2, there's our number 3. So in this case, once again, we start here, 1, 2, 3. So that's clockwise, but we need to flip it around because our H is coming toward us again. All right, got that one squared away. Let's look at our last one now. So once again, O and H, there's my 1, there's my 4. Here, down at the bottom, I have CH2 bonded to a C. Here, I have C bonded to an O. I don't even care what else it's bonded to because O beats out everything that this is bonded to down here. So in this case, we have 2, 3. All right, so I start here, 1, 2, 3. That is clockwise, but of course we have our H coming toward us once again. Sorry, that's counterclockwise. I know how to read. I was going too many steps ahead. So this one is going to be R. So we have S, S, R. For this one, there's no internal plane of symmetry. Why do I know that? If I look right there and look right there, those are 2 different substituents ultimately. So this is a chiral compound as well. All right, next one. Okay, so for this one here, we have a chiral carbon right here. I got a bromine and a hydrogen, and then I got carbon, carbon. So I already know I'm gonna have to break a tie between these two eventually. But right off the bat, I can say, okay, that's priority 1, that's priority 4. Now, when I'm breaking a tie, I can look at this here and that. This is bonded to 2 H's. That's also bonded to 2 H's. Okay, so now we move to the next ones. So now we're going to compare this carbon with this carbon. This is bonded to 2 H's and then another carbon, right? And this one here is bonded to 1 H and 2 carbons. If you have a double bond to a carbon, that's 2 bonds to a carbon, right? So this one is going to take priority over this arm right here. So this arm is more important than this arm. All right, and in this case, we already have H, our 4th substituent, going to the back. So all I have to do is draw my counterclockwise arrow here, and that puts us at S. There we go. One more. Okay, with this last one, let's draw our hidden hydrogen here. So I already know that this carbon is the only real interesting one here. So we need to determine if it is chiral. So I'm going to look here to see. I already have these. These 2 are different already. So these are tied still. Now we move to the next one. These 2 carbons, they're actually the same also. And then as you move around, you just basically get right back to this spot. So this is not chiral. So there's nothing else for us to do. That is not a chiral carbon. All right, I just want to show it on there so that you can see, what something that isn't chiral looks like, even though it appears that it might be chiral. Okay, so that's all the questions for this one here that we talked about identifying chiral carbons, RS configurations, and then determining if a compound overall is chiral or achiral. Next video will be on converting between Fisher and perspective projections. So stick around for that one. Thanks.